Today we're looking at free fall here. This video is designed to hopefully help you with the free fall worksheet that I posted this morning. Also, there's free fall notes, which I'm hoping are pretty thorough. Make sure you read through those. Don't just glance over them, but read it word for word, try to understand it, see what you can get out of it, and then use this video as a supplement to that. If you need additional help beyond that, I've already had students reach out to me about helping them with this or that in this chapter, so just feel free to do so. Okay, so free fall. Section 3 of chapter 3 is defined as the motion of an object when gravity is the only significant force acting on it. Now, second definition here, acceleration due to gravity, denoted with the lowercase g, by the way. It's the acceleration which is gained by an object because of the gravitational force acting on the object. Now, on planet Earth, the acceleration due to gravity is, for all intents and purposes, it's 9.8 meters per second squared. All right, 9.8 meters per second squared. You're going to use that number an awful lot as we proceed through the rest of the course, so it's a good idea to go ahead and just commit this number here to long-term memory. Now, I want you to note that this number is always a positive number, all right, generally speaking, and also the downward direction is positive unless otherwise instructed. There might be a couple instances where the downward direction is not positive, but generally speaking, for our intents and purposes, gravity, the acceleration due to gravity, 9.8 meters per second squared, is going to be a positive number. Now, free fall problems here consists of two parts. Part one is, well, first of all, you're going to be provided with a little bit of information, and it's all the information you need to help solve the problem. You're going to be provided with a time value, an object of some sort, and what's happening to the object. Generally, it's thrown over a cliff or it's dropped from wherever. So you'll know what you're working with here. Now, the first equation there and the second equation I don't know if that helps or not. The first equation and the second equation here, you've seen both of these before. All right? When we're calculating the speed of an object after X number of seconds in free fall, in this case 3.7, this equation, you might recall, maybe it looks familiar to you, is your equation that is used to calculate final velocity with average acceleration. All right? This equation here, where we're calculating the distance that the object falls, this equation is your position with average acceleration equation. So neither of these equations are brand new to you. All right? We focused on this with a worksheet, and we focused on this one as well. I think I made a video for this, and I know I made a video for this one for sure. Now, what we need to keep in mind here, though, is that since we're talking about free fall, it's this idea that the acceleration due to gravity, right, needs to be accounted for every time. So whenever you see the acceleration value in this equation and this equation here, both part A and part B, the acceleration due to gravity is always 9.8 meters per second squared. All problems that we're going to focus on, hypothetically or otherwise, are taking place on planet Earth. If we were to go to the moon, which unfortunately we can't right now, but if we could, then the acceleration due to gravity would be a different number. It'd be like 1.63 on the moon. All right? But the idea here, my point is, the acceleration due to gravity on Earth is always 9.8. So when you're working with free fall problems, you always know the acceleration. I don't provide it to you. You just need to make sure you know it. All right, so commit that number, 9.8 meters per second squared, commit that to the frontal lobe of the brain, and retrieve it often. Now, what we're talking about here for part A, calculating the speed of the object after 3.7 seconds in free fall. Notice the golf ball starting from rest. It started from rest. The initial speed then is going to be 0. All right, so you got v sub I, we have acceleration of 9.8, and then we also have the time of 3.7. You always know what the time is. It's going to be provided to you. So then 0 plus 9.8 plus, 0 plus 9.8 times 3.7. You get an answer of 36.26 meters per second. That's all you have to do to figure out the speed of the object after X number of seconds of free fall. And again, you'll be provided that time. Now, just for reference's sake, this in miles per hour, because this is fast, okay? How fast is it? It's like 81.11 miles per hour fast. Now, what you need to keep in mind is we're doing these problems, and we're not accounting for air resistance, because that opens up a huge can of worms that takes us well beyond the scope of a high school level physics class. So we're just going to always ignore air resistance. All right, unless I say otherwise, and honestly, I don't know if there's a time where I do say, oh, we have to account for air resistance, because again, that goes beyond high school level physics. All right, so to figure out part A, all we're doing here is taking the gravity of 9.8, acceleration due to gravity on Earth, times 3.7. That's it. Now, for part B, you want to calculate the distance that the object falls. Here's the formula. Again, this is the same formula for position with average acceleration. Keeping in mind now, we're talking about things falling. So we're accounting for gravity. All right, so acceleration is always 9.8. Now, when you plug everything in here, the initial distance is always 0, just like it was before. The initial speed is 0. Why? Because it says it starts from rest. The time is 3.7 plus 1/2 times gravity times 3.7 squared. You multiply these numbers together, you get 67.08 meters. Now, some people may say, oh, it's 70.78 meters. That's not right, okay? The 70.78 meters is not right. And here's what they're doing. They're adding this to all this over here. In the notes, I'm referring to the thing called PEMDAS, the order of operations. Please excuse my dear Aunt Sally, whatever else little saying you remember to help you remember that order. So you always do the multiplication first. That being said, 0 times 3.7 is 0. So that we can basically just get rid of this and focus on everything to the right of the plus sign. 1/2 times 9.8 times 3.7 squared. Your correct answer, 67.08 meters. Okay? All these problems are done the exact same way. It's always a two-part problem. Part 1, you will figure out the speed that the object has reached after however many seconds it is. 1.7, 3.5, whatever. Part 2 is always figuring out, okay, here's the speed of the object, how far is the object falling? Just before it hits impact, how far did it travel? Vertical. All right? Please keep in mind the vertical orientation for these types of problems. All right, we're talking about free fall. Okay. Now, so take a look at those notes and make sure that you're reading through that. Maybe you have to watch this video a couple times to get it to fully understand it, which is fine. That's why I'm posting them for you. But if at any time, like I said, if you need to reach out to me, if you need me to come to work with you one-on-one or small group, I am more than happy to do so. Just let me know.